The winner of the 2025 Solar Builder Project of the Year Award for the Microgrid category is the Orcas Center in Eastsound, Washington. Located on the remote Orcas Island in the San Juan Islands, this 100 kilowatt PV plus 1.3 megawatt hour battery energy storage project provides grid backup and energy resiliency for the community center, which offers essential cultural and community services, as well as serving as an emergency hub during power outages. Here to talk about the project are Marcus Berta and Callum McSherry, both managing partners with Cascadia Renewables and Sulis Energy, the developer and EPC on the project, and Lucas Miller, senior engineering consultant at Mayfield Renewables, which provided permitting and construction support. Well, gentlemen, thank you for joining me today. I wanted to start off with a little background on the Orcas Center, how this project came together, and why it was necessary.
This project was really unique in some ways, in that it was the first project that we developed and got installed kind of steel in the ground at Cascadia Renewables after founding in 2022. Pretty early on, the executive director of the Orcas Center, his name is Dimitri, found his way to us through a local kind of community benefits organization that was helping him with some energy efficiency work and some grant funding work. And he had been talking with a local solar installer about battery backup and enhanced resilience for the Orcas Center that played a really important role in emergency management during the COVID pandemic. They were the vaccination hub for the island, and they became not only a designated mass care facility, but also a joint command center for the different authorities under the emergency management umbrella. And so he was thinking more about, what does it mean if we have a prolonged electrical outage at the facility, and how could they prepare to continue to provide those services for the community? He didn't have a backup generator, and so he wanted to look into both, the backup generator as well as clean of a backup source of power as possible.
How does this project impact the community there on Orcas Island?
This project was really exciting in that it's a site. The Orcas Center isn't exactly what you would think of when you think emergency management. It's a performing arts hub and a cultural hub for the island. As we were looking at the kind of comprehensive emergency management plan for the region, there wasn't a designated mass care facility or, resilience hub already. And, in talking with the emergency manager, it was clear the priority for them was to build that resilience asset where the community was already gathering. That was a bit of a light bulb moment for us. It made sense that this site should be invested in, and the willingness of the Orcas Center staff and team to expand their services to include kind of, really important resilience assets was generous, I think, of them, and really represented their commitment to the community as well.
It's quite a unique scenario to be in, and really trying to understand that we had to abandon some of our typical preconceptions about how this system would operate and what the scenario would be. Often we would anticipate that there would be a reduced usage of the site in an emergency scenario. In this instance, actually, there's going to be an increased usage of the site because it would be operating sort of as a coordination hub and mass care facility. So going through and doing both manual load calculations to sort of say, okay, well, which actual circuits are going to be used and to what degree beyond on a typical day, and being really careful about how we sort of portioned out generator usage with it. If you imagine sort of a worst case scenario here, we're talking about a catastrophic earthquake and possible tsunami, and there could be multiple weeks worth of waiting until any kind of support could come to the island, including refueling of the generator. So one of the things we had to consider was, well, how do we optimize this so that the generator fuel reserves can last for multiple weeks without needing to be refueled, and what does that mean in terms of daily runtime? So I think that was one portion of it, was just working with the community to understand this isn't the same as a similar facility on the mainland.
Speaking of the actual installation of the project, I understand there are some technical challenges. Can you talk about those and how your team overcame those obstacles?
So there are a few different parts to this. Obviously, we're very lucky, I'll just say, to have a fantastic network of colleagues and other partners that we work with through this project that help us overcome a lot of these hurdles. So the first is the fact that on the site as a whole, you had 2 different electrical services with different phases. And in order to try and get the maximum benefit out of the system, we needed to combine the services, switch the phase of one of them, and really try and ensure that the site as a whole had as much flexibility in how it could be used in an emergency as possible.
Mayfield Renewables was the electrical engineer of record for this project, and we got pulled in after equipment selection had happened. So Cascadia had already performed a preliminary analysis feasibility study for this project. The results of that were shared with Mayfield's, and most of our work from that point onward was figuring out the best location for all of this equipment, trying to co-locate it for ease of maintenance and installation, and also a lot of work on controls coordination. So this system has not 1, but 2 electrical relays that need to communicate with each other dynamically in an islanded or non-islanded situation to control the dispatch of the generator, BESS, and PV systems in real time. So a lot of our effort went into developing a construction and permit set, but also in coordinating with all the controls partners involved in allowing these electrical resources to talk to each other to ensure that all the load is met at the Orcas Center in an islanded scenario. When the BESS falls below a certain state of charge, the generator will kick on, provide backup load to the facility, and also recharge the battery without backfeeding the grid, and then turning off when the grid does come back on and ensuring that we're not paralleling at any time between BESS and generator.
I will give my business partner an "I told you so" on record, because he did suggest it was going to be a risky proposition to try and use ground screws out on the island. In the event that you have a refusal of your ground screws once you start working, there's not a great deal you can do. So re-engineering that solution quickly to avoid a sort of lengthy delay in the installation of the project really was supported by our civil and structural partner, Facet Engineering, who came up with an alternate solution, and by sort of speedy work from Mammoth Construction, our civil contractor, for that portion of the work. And obviously, in a scenario like this, you're working with a community that doesn't have the resources to absorb a costly change order. So trying to figure out how to make those changes work within the budget and within the schedule of the grant was challenging. But again, I think just there's a lot of goodwill from all partners. Everyone understood the parameters we were working within, and overcame that relatively smoothly and quickly.
One of the things that stood out to me with this project was the importance of community engagement. Can you explain why that was so crucial and what the project team did to ensure that support?
In some respects, it didn't take a whole lot of pushing and asking to get the community to show up to help support this project. But I think it was really critical for us to value that feedback and understand why listening is important. You know, if you've ever been to the San Juan Islands, you can really feel the community out there. It's a small community. Each island is unique in and of itself, and each island has a really small, unique community. When we were filming the case study, there was a group of, elementary school age children filming a dance recital to Beatles music. Like you go to the site and you just can't help but feel really warmed by how it really is this hub and this center point for the community. When we were, doing our initial feasibility and design optimizations, we worked with Dimitri to understand, not only the what and how of the project, but really the why. And with microgrid optimization, that is really critical to what Lucas was saying. When we're trying to optimize the dispatch of these kind of complex energy systems, understanding the scope of the community's goals is really critical to getting that dispatch optimization right. The scope of the project really expanded out to where the local serving cooperative utility was really supportive as well, to the point where they wanted to land a fiber optic cable into the microgrid controller so that they could help monitor and re-optimize the system over time to both support the resilience goals for the Orcas Center, but also the, managed grid constraints.
The other side of this, in terms of the community engagement, is I would just name the fact that there's a lot of anxiety around battery energy storage systems in general, particularly commercial ones, in various communities around the states, and Washington is no different there. We did get feedback from our team that while they were out there, they did have local community members coming up and concerned about the system and wanting to understand more about it. And so making sure not just on the front end that you're sitting in a room with people and having a conversation and then sort of think, job done, now we can walk away, community engagement finished, making sure that throughout this process, at any point in time when the community is engaging with the project, they're able to be listened to get a thoughtful response and to learn. And and the upshot of that was that we didn't have sort of any kind of escalating concern or major protests through this. Very valid community concerns were expressed throughout the project at different points, and we needed to make sure we could meet those at every point.
To kind of wrap up, I kind of like to ask each of you, what was your favorite aspect of this project?
So Mayfield engineers a lot of community resilience hubs and small microgrids designed for similar purposes, but funny enough, this one actually, Orcas Center is a building that our CEO knows well. He's from the San Juan Islands, grew up on neighboring San Juan Island. And as we're going through, project material, including prep for this interview, he was just noting how he spent his childhood in and around that building and just noting how much has changed, how much is the same. And so we've worked on a lot of these, but I don't think we've ever had one that hits this close to home.
I think it's probably the most visceral example of resilience need that we worked on. It's not to downplay the fact that there's vulnerable communities everywhere, and that if you have a single service or a long distributional transmission line, you could be equally as vulnerable from an energy perspective, perhaps. But flying into Orcas Island, you can just see laid out the fact this is a literal island. And you really get a sense that what you're doing is very important to this sort of small but very close-knit group of people.
I really found a lot of joy in the collaboration that came together on this project. We had something like 15 different project partners, all who were, experts and brilliant at what they did. Callum had mentioned the civil challenges we'd had. We had all sorts of pretty incredible logistic challenges. If you can imagine getting a, large lithium battery pack to a remote island via ferry. So everyone really understood the goals and the mission for the community and started pulling in the same direction. And that is an inspiration to me, that we can replicate this and really start to deliver resilience to communities when we work together.